come in the GATE examinations based on this stack and queues. Okay. Now, I hope that algorithm which I wrote yesterday was clear to you, and therefore it's not difficult. And today also it's a similar algorithm what we have done in the last class, except that you should know that it's a deletion algorithm. Now, okay, Utkarsh, I'll do that today. Okay, fine. Now, let me start with Q delete. Now, again, I am telling you, if I speak Q, it means a circular Q. Whenever I speak Q, it is nothing but a circular Q. Now, let us come back. Now, what you have to do is that you know that what you have done yesterday is that we have a queue like this. Where we are having say, this is the front end and this is the rear end. Deletion will always be done from the front, therefore this is the delete. Okay. Now, first of all, if you want to delete from a queue, you should know that deletion is only possible if queues are having elements. If queue is empty, you cannot delete. Then what you have to check is that you have to first check is queue empty. Now, how will you check? Is queue is empty? It means if it is empty, the front pointer will point to null. That means I say if f is equal to null, then print nothing to delete. And then you can return. There's nothing to delete because obviously there are no elements. Now you can also check with r is equal to null. Both are same because f and r will be both will be null. But since deletion is being done through front, therefore I'm writing front. Otherwise, you instead of writing front, you can also write a r, or you can check both of them because it's also not possible that one of them is null and other of them is having some integer numbers. Obviously not possible. Therefore, whenever f will be null, r will also be null. But I need to check only one of them because there is no need to check both because of the fact that one will be sufficient. Okay. Now what you do is that suppose the elements are over here. Let us take elements are A, B, C, and D. Now 4 elements are there. Now obviously you can only delete A because that is in the front of the queue, and therefore you have no other elements which you can delete. Now what I can do is that now here the numbers over here are 1, 2, say 3, say 4, and then 5. And let us take this as say 6 or max. Now once I want to remove A will come out and the pointer front will point from 1 to 2. Now initially, now in this case it was pointing here. and R was pointing to this place. R was pointing to this place. Now once I remove the A, F will now point to B. That means in the second I will say delete the front element. And let us take the variable as say element is equal to, let us call it a Q, is an array, and I will use the front pointer. I will use the front pointer to delete. That means here what will happen is that now here what will happen, element will become equal to A. Then what you do is that you set the pointer F. You set the pointer F. Now the third case is that you will set the pointer F. Now here I have to see what are different cases. Now what I will do is that I will try to set, I will say third, set the pointer F. Now here we will understand what are different scenarios. Okay, let us try to understand the scenarios. The first scenario is this one. Now A, B, C and D. Front is at this place. Rear is going to be at this place. Numbers will be at 1, 2, 3, say F is N. Now you want to delete the first element, whatever you want to delete. Once you delete A, F will point to F plus 1. That means you have deleted A. If now in this case what will happen? F will become F plus 1. From 1 it will move to 2. This is now called a normal delete. It's a normal delete. That means you are having the elements over there. R is before F. Now the meaning is that R is having a bigger value. Now in this case, R is having, that means this is having R is bigger than F. R is having a value of 4, F is having a value of 1. This is a normal Q delete. Now second case would be like this. Let us take this example. Suppose we are having A over here and there is only one element. Now what will happen? F will point to this place. R will also point to this place. It means that R is equal to F. Now what you have to do is that you have to delete only there is only one element. Therefore you delete A. Once then you are going to delete A over here. You will delete the variable A. And what will you do? You will write R is equal to 0 and F is equal to 0. Now you know that in the case of insertion in the queue, once I inserted the first element, I modified both the pointers, the F and the R. Similarly, in the queue, delete, if there is only one element, when I am deleting that element, I have to modify both R and F. Otherwise, in the first case, you are only modifying F. But in this case, you are modifying both R and F. Now, the third case is this one. Now, suppose you are having A, B, C, D. Let us do it like this. Suppose I am having, say, over here A, and let us try to have this value as equal to F front, and this value is equal to R. Now understand this third case, which is little different from first. Now what is the meaning of this? What is the how have you come to this position? Now what is happening over here is F is R is less than F. Now can anyone answer that when you will get this scenario? Or is this correct? Or it is wrong? Okay, tell me, does it look correct? But is something wrong over here? हाँ बताओ, is it correct or no?
Not sure, sir.
No. Why?
Sir,
You are correct. It's wrong. It's wrong. But why it's wrong? Can you get a queue like this? No. Why?
sir.
Sir, as
Yeah,
sir, as the insertion is always from the rear side, so rear should always be greater than the front side.
no, it may not be, because
Yes, sir.
if the R
Yes,
has
sir.
rotated, this case is there. R can be here. It's no problem. But what is happening is that if F is at this point, if suppose this is the number is 1, 2, 3, 4, 5, and 6. If F is at 6, it means that it has come to 6 by deleting 5, 4, 3, 2. Therefore, if F is at this point, it means that these elements cannot contain any values. Now let us try to make it clear. Now this one will state you that why I said that this should not be there. These are wrong ones. Now let us try to say, I insert 5 times. Okay, A, B, C, D, and E. Okay, now rear will come here and front will come here. Correct? Now I delete. Now understand my words very clearly. I insert 5 times. This is the status. Now I delete one item. What I did, I insert 5 elements. Then I delete one element. Tell me, what will happen? Where will F go? If I delete one element, where will F be? Obviously,
At the position 2.
it will always delete this one. That will what will happen is that it is going to delete this one, and then what will happen? F will point over here.
B.
F will point to this place.
Yes, sir.
Correct? Fine. Now, what I will say, I will insert one element. What will happen? The circular queue insert will come into picture, and this is a case of rotation. Therefore, you might be entering, suppose I want maybe entering P at this position. Obviously, this is the way.
Yes,
You are
sir.
going to rotate from here to here, and then R will point to this place. And what I am doing is that now this R will go. Any problems? The case of rotation in the last.
No, sir.
Fine. Now I delete 4 times. At least sorry 3 times. What will happen? You will going to delete this one. You are going to delete this one. You are going to delete this one. And then what will happen is that this will come over here. Correct? I delete 3 times, therefore you are going to delete from here, from here, from here. Correct? Now, can this be the status correct? It can be correct. Now, therefore, I said you come to this place, which I just, this one. Even if this is the same as this one, but if F is at 6th position, 5, 4, 3, 2 will not contain any data. That means if F is at 5 position, if here F is equal to 5, then 4, 3, 2 will have to be empty. Therefore, it is not possible that these places you will be getting data. And therefore, what I wrote over here was intentionally wrong, just to make you aware that this status cannot be there. Okay? Now fine? Now let us try to delete one element from here. Now what I was trying to do over here is that if I will remove all this, and now I will come with this one, that this is the actual, this is the now the actual one. Let's come. Okay, now this is the actual scenario. Now you want to delete one element. Now here you want to delete one element. Now R is less than F. Now somebody told that R will always be bigger than F. It is only possible when rotation has not taken place. Once a rotation has taken place, R will always be less than F. In normal Q, R will never be less than F. But I told you yesterday only that we will not discuss a normal Q because normal Q is having a big problem. Now just I'll explain in after 5 minutes why I said that normal Q is not possible to be used. Now if I'm having like this one and here I have to delete, I will be deleting say F. What will happen? The rotation case will come, and once you are going to delete this one, F will have to now rotate from here, and it will rotate and it has to come here. It has to come here. Okay? Then what we are going to do is that if this case is there, what you are going to do? You are putting the value of F is equal to 1. And this is the case which is important to know. Therefore, I will be just highlighting it again, just to make you aware that this is the case of rotation. Whether the other two cases are normal ones, which is normal Q. Therefore, if you are implementing a Q using a normal Q, obviously only you will get the first and second case. If you are implementing a circular Q, the third case will also come in picture. And therefore, now our algorithm will just be able to modify, will be just adding these 3 cases and the whole algorithm will work. Now let us try to show you like this. Now what I am going to do, I will set the pointer F. Now let me translate these 3 cases over here. Now the first one is that if front is equal to rear. That means the second case. Now this is case 2. Just for your reference, it's case 2. If front is equal to rear, then Q print Q has only one element. And then what do you do with that? You are putting F is equal to 0 and R is equal to 0. This one. Second case, else. Else. If front is equal to, say, max. This one is max. No, this is the max. Then what you are going to do? You are putting F is equal to 1. This is case 3. If it is not there, then there is the first case, which is the normal Q, F is equal to F plus 1. And this is case 1. That's all. You stop.
Sir, the last condition, sir. Once again, sir, please pardon, please. Else if F is equal to max.
See, why I am writing at a third place? Because first I will check if there is only one element. Now case 2, this is the case 2. If there is only one element, F will be equal to R. You see, here F and R are the same position. It means there is having only one element. Now if you delete that element, the Q will become empty. That means if F is equal to R, then print Q has only one element. You set the value of F is equal to 0 and R is equal to 0. That means Q is now empty. Otherwise, if this is not the case, it will come to else. And you will find the third case. When F will come to max, then only rotation will take place. Now in the second case, what is happening? F is at max. And once you delete F, it will rotate to the first position. Therefore, if X is equal to max, F is equal to 1, that is the case where F was, in this case, what was happening is that F was at 6. F was at 6. And what you did is that you rotated this and set it F at here. That means rotation took place. You move from 6 to 1. There 6 is max. Therefore, if I write if F is equal to max, then what you do is that you put F is equal to 1. That is the case number 3. And if it is not case number 2, not case number 3, then it is case number 1. If it is not 2 and 3, that means it is not a case with single element. It is not a case with rotation. Then it has to be a case with the normal Q. And what I am going to do is that I will just write F is equal to F plus 1, which is this case. Okay? If you are going to write in other ways, you will have to write a lot of if else. If I write this way, I can write a single nested if and can do. That means it checks the first condition, true, case 2. If it is not, then check the third condition, true, then it is F is equal to 1. If it is not 2 and 3, then it has to be 1. So these are only 3 possible deletion cases are there. And therefore, this is the case. Now it is going to give you a physical F plus 1. And now you have set the pointer F over here. Okay? Is it clear?
Sir, sir, regarding the case 2, when we initialize a Q, we put front equals to rear equals to null. So just suppose that if the Q is empty, then also we have front is equal to rear.
Correct?
So if we are putting case 2.
See, but here you might see that I already checked it in condition number 1.
Okay. I didn't see that.
Okay. Then nothing to, and to return from there, it will not come to 2 and 3.
Okay, sir. Okay.
Correct? Because this is already there. If F is equal to null, therefore I will print nothing and then I will just return. 2 and 3 will not go. Correct? Therefore I am testing it over there before only.
Okay, sir.
Fine? Anybody having any problem? See, please be clear. Otherwise, these algorithms has to be translated into some actual applications, and therefore at that time we should be very, very clear. For example, if I am going to implement a priority queue, it is nothing but a circular priority queue. Therefore, if you are not very clear with this, it might become difficult over there to understand. Okay, now let me come to this column and let us try to see that. Now let us try to make one queue like this. Now, if I write, say, their number is, suppose I write 1, 2, 3, 4, and 5. Okay. Now I write, say, P, R, say S. Now tell me, what is the value of F and what is the value of R? This is status. Where is F? Where is R? Obviously, there could be only two choices. There could be only two choices. That means it could be F could be here and R could be here. Or R can be here and F could be here. Isn't it? These are the only two choices. Obviously, it cannot point to a blank one. Now, which one of this is correct? That means F could be 2,
F equals to 2, R equals to 4.
or 4, and this will be either 4 or 2.
4 or
बताओ
2.
इसमें से कौन सा सही है?
सर
फर्स्ट वाला सर नॉर्मल क्यू के लिए है और सेकंड वाला सर सर्कुलर क्यू के लिए है।
नहीं, दोनों के लिए केस एक ही होगा। ऐसा नहीं है जब स्टेटस तुमने बना दिया तो नॉर्मल और सर्कुलर कुछ नहीं है। ये स्टेटस तुमको किसी एक ही कंडीशन में मिलेगा। हम लोग नॉर्मल क्यू की बात ही नहीं कर रहे हैं। We are just talking about a circular queue. Now let us try to understand. अगर मान लो हम मान लेते हैं कि ये तुम्हारा रियर है और ये तुम्हारा फ्रंट है। Now tell me, is it possible? Obviously possible है। कैसे है?
Yes, sir. It is possible.
Because तुमने 4 बार इंसर्ट किया, एक बार डिलीट किया।
Yes, sir.
ठीक है?
2 or 4.
Inserted
हाँ
4 times and delete 1 time.
1.
ठीक है? Okay. Now let us try to do it reverse way. यहाँ पे है तुम्हारा R और यहाँ पे F। ये पॉसिबल है?
इधर हो गया यानी।
अब बताओ R2 पे कब आया?
No.
When would have R come at?
सर रोटेट की सर हमने 2 बार रोटेशन से इंसर्ट किया है और उसके बाद हमने इसको डिलीट कर दिया।
That means if R is at 2, it must have come from 1 to 2. है ना? कैसे हुआ? Let us now show you.
Yes
Let
sir.
me try to understand. एक बार बताया था, then you will try to understand. For example, I might have entered say K, then S, then P, then R. Then maybe T, then over here. Now here, R was here, and F was here. ठीक है? Then what I did, I deleted the numbers from here. I deleted numbers from here. Now I deleted this one. Then F will come here, Then now I inside one number. Maybe say I inside X. Okay. Now I deleted, say I deleted 3 times. One time, 2 times. Okay, let us say I delete only 2 times. F will come here. And this one is now at this position. Is this correct? This can be there. Now that is why I tried to misguide you. This type can never come. Therefore, this is just a case which I was trying to make you over there. I just told you in the last slide that if F is at this position, R cannot be there. Therefore, if you see this slide, just see if R is at this position and F is at this position, these all must be blank. These all must be blank. Now, what I said is that if A is over here and F is at this place, these all must be blank. Now here you just see the same thing. R is here and F is here. It means this cannot come. Now this means this cannot come. This cannot come. That means this was wrong. You should see the Q and tell that this is wrong. It means that this cannot happen. It is only possible if R is not there. Now what I will do is that if I remove this, if I remove this, then it is fine. F and R will be, now in that case, it is fine. You are going to delete elements from there. You are going to delete elements. It is a rotation case and it can be like this. Just like this one. Just check. Isn't it both are over there? Now in this case, this could be there. But we cannot have elements over here. You cannot have elements like, for example, I cannot have, say, K over here or say M over here. It is not possible because if F has come to R, it must have deleted M and K and then only it has come to R. If F has come to this place, it must have deleted this, then only it will come here. It cannot bypass M and K and come to R. Now in this case, this is correct. Now let us try to do another one. Okay, this is the case. You are having, say, over here you are having A and you are having, say, B, C and D. Now tell me, where is F, where is R? Shall I write R here and F here? Is it correct? No. Why? Because अभी बताया कि इसमें खाली नहीं हो सकता. It means that this is the only way. That means this has to be this one. This has to be an R and R. अब ये ठीक है because you insert 5 times and deleted 1 time. That means R is at 2 and F is equal to 2 and R is equal to 5. Now this is fine. This can happen. Now let us try to do another one. But tell me, first, is it practically possible or not possible?
No.
Why no? That is the answer I want. You may be correct. Tell me why this is not correct. R is at say 1, 2, 3, 6. Now here R is equal to 6. F is equal to 1 and R is equal to 6.
So because to move R to 6, we have to have elements in between 2, 3, 4, 5.
Correct.
Because
Means that this is wrong. Because if R is coming to 6, it must have filled 5, 4, 3 and 2. That means this is wrong. Now let us come to this place. Is it okay for all of you that R cannot come to 6th position without filling 5, 4, 3, 2? Now let us come to this one. Is it possible?
yes, sir.
Yes, it is possible. Because it means that you have inserted maybe 6 times, deleted 3 times. It is normal cube. Now, if you are going to interchange over here like this is not possible. In this case, F cannot be bigger than R. Therefore, if this is now you see the previous case. This is okay. R is bigger than F is correct. But it is not like this. If I write F over here and R over here, it is not possible. Because if this is possible only when there is no A. It is only possible when there is no A. No, it's fine. This can be there. This can be there. Or no? No. Why? Again, same thing. If R is at this place, these all must be full. These all must be full. Therefore, you see over here, the case what I said, R was at the first position. And if R is at the second, third, fourth position, the previous must be filled. Therefore, in that case, if R is at this position, these all must be filled. This must be filled. Now that means if I am going to just show you the Q, you can very well tell whether it's possible or not possible. Okay, this is totally possible. Perfectly valid. But this one, now in this case it means that this might be having say F, okay, this might be in B, this might be in C. This is valid. But if I write over here B in C with F and R, it is not valid. Because B, if B is here, this must be filled. This must be filled. You cannot skip the previous one and come to the next one and fill it over there. Therefore, this R pointing to 1 and F pointing to max is perfectly correct. But R pointing to more than that, it is not possible. Now let us try to understand one more. Now just try to understand one thing.
Possible.
Correct. It's possible. Why? Because R has come over here, say to 4th position. by filling 1, 2, 3, 4. Now, if I ask you how many minimum insertion deletion has taken place, if I ask you how many minimum times it has taken place, now obviously when R is less than F, it means the rotation has taken place. Therefore, now try to understand it very well. So for this, minimum number of minimum insertion कितना हुआ होगा और minimum deletion कितना हुआ होगा?
So 10 insertion, 4 deletion.
Why I say minimum? Perfectly, what you said is okay. That means it has to be at this means has to be 10 and it has to be 4. Because first it might have moved 6 times and it inserted 6 times. Then there could be say 2, 3 deletions, and then in that case there were some more insertions, rotated and keep on inserting. Therefore, after 10 times, this will come to this place. And therefore, once I am coming to this mean, it means that there has been one rotation of R, but no rotation of F. Now, this is just one of the scenario. Now, this is because I wrote minimum. If I don't write minimum, I cannot say for sure. Why? Because there might have been many insertions, many deletions, and this could have come after say 40, 50, 60 insertion deletions. But minimum, it must have inserted at least 10 times, because inserted once here, 2, 3, 4, 5, 6. There are some deletions. Then again, this has not become empty rotation. Then deletion insertions. And this is what you said is perfectly correct. Okay. Now that means you have to if F is always bigger than R, it means the rotation has taken place. It is a simple case. If you see in the last algorithm, if I wrote over here that when I say F is bigger than R, it means it has to be rotation is there. Otherwise, if it is not like that, it means there is no rotation. If R is less than F, there would not be rotation. Correct? Now, just to revise all this, when I come on a Tuesday, I'll give you some problems, and then you will be able to tell that whether it is possible or not possible, and you have to fill the queue. Now, what I'll do is that I will give you the values of F and R, and with those values, you have to tell what is the status of the stack, sorry, status of the queue. And by this method, you will be able to tell me that whether it's correct or not. Any more questions?
Excuse me, sir.
Ah,
Sir, I could not understand how did you calculate the minimum insert 10?
okay, see. Now let us come to this question. Fine. Good. I want that you should be able to ask me. See. Now let us try to take a normal Q6 with this. Okay. Now, if you are inserting say 6 times, what will happen? You will get say A, B, C, D, E, and F. And R will come here, and F will be at this place. That means you have done insertion, you have already done insert, you have done equal to 6 times. Correct? Now you can't insert anymore. Now here, R is bigger than F. This is normal queue. If I delete say 2 times, what will happen? You will be able to remove this, you will be able to remove this. And F will now come to this place. That means deletion will be 2. Now suppose I insert 2 times more. 2 times more. Suppose I insert 2 times more. Therefore, G will insert here and H will insert here. Now R will now move from here to here. Now you have inserted 2 times more. Correct? Now, what happens is that you are going to delete 2 more times. You are going to delete 2 more times. Then what will happen? You are going to do it over here. This one, and F will come, and now F will come over here. Correct? It is having 2 plus 2. But now here, R is at 2. But I want R at 4. It means that to make this at here, you have to insert 2 more times. Because here, R की value जो है 4 है. यहाँ पे R की value 2 है. That means you have to do at least 2 more insertions. हमने मान लो किया फिर भी C और D. तो तुम्हारा R जो है यहाँ से यहाँ आ गया. और यही तुमने 2 बार और ऐड कर दिया. ओके ना, ये गलती थोड़ा सा यहाँ पे इससे 4 नहीं था, 5 था जैसे, तो 6 है ना. ये डिलीशन हुआ होगा 1 time, 2 times, 3 times, 4 times, 5 times. It's not 4, it should be 5. Why? Because of the fact that there are 6 elements and F was at left. Therefore, अभी इसमें से क्या फर्क है? F is at 5 and here F is at 6. Therefore, one more deletion. एक और deletion करो. Therefore, what I am going to do? I am going to delete this one. So, what will happen? F will come to this place. No, you just check this two. ये दोनों सेम नहीं है. एलिमेंट्स का फर्क है, बट स्टेटस इज सेम. तुमने इंसर्शन कितना किया? 6 plus 2 plus 2. एडिशन तुमने किया एक बार और किया 5. Therefore, this would be 5 and this would be 10. Correct? Now, if you are going to do it, say n number of time, keeping on doing, it will keep on rotating. Yani it could also be 20-10. It could also be 30-15, and so on. Therefore, there are a lot of scenarios. But this is, see, R जब 4 पे आएगा, इसके मतलब कि रोटेशन हुआ है. रोटेशन कब होगा? जब 6 times इंसर्शन होगा. उसके बाद R4 कब होगा? जब 4 times इंसर्शन होगा. That means 10 times इंसर्शन होगा. R4 पे है और F उससे बड़ा है, इसके मतलब रोटेशन हो चुका है इसका R का. अदरवाइज नॉर्मल केस में R हमेशा F से बड़ा होता. If R is smaller than F, it means rotation has taken place. If rotation has taken place, it must have at least filled 6 times to rotate and then 4 times more to come to 4. That means 6 plus 4 is 10. Therefore, this is perfectly 10. If 6 पे है, इसके मतलब ये हुआ कि कम से कम ये 5 बार डिलीट किया होगा. That means this is at 5. We have 5. Any more questions on this? Is this correct? What I spoke? One question. Who are asking?
Yes, sir. Clear.
Clear. That means जब भी वैल्यू अगर ये केस होगा, let us take this value. ये वाला केस है मान लो. रोटेशन नहीं हुआ है. How will I know? तो R is bigger than F. अभी से पूछेंगे मिनिमम इंसर्शन कितना हुआ है. Obviously इसमें इंसर्शन कितनी बार हुआ होगा देख लो.
5 और डिलीशन 1.
That means इसमें जो है इंसर्शन जो हुआ होगा वो हुआ होगा 5 times. Because when R is at 5, it has at least inserted 5 times. Deletion जो हुआ होगा, minimum deletion obviously is 1. अब यहीं पे एक चीज पूछे थे तुमसे, ये हमने कर दिया इसको.
ये तो पॉसिबल नहीं है.
Correct. It's not possible. Because, first of all, if R is 2, this must be filled, this must be filled. And if F is bigger than R, C and B cannot be there. This means this is also not possible, and this is also not possible. That means this should have been like this. It should have been like this. It should have been like this. Maybe if D is here, A is here, it should have been some value, say S over here. And then I can say ये R है और ये F है. ये true है.
So there should be value after D as well.
Correct. This is wrong because there must be some value, say K at this place. Then only, because if you will delete D, it will blank, point to blank, which is not possible. Therefore, there must be some value K over here. And therefore, in this case, you might say कितनी बार insertion हुआ होगा? Obviously, 6 plus 2, 8 times कम से कम insertion होगा. Deletion कितनी बार हुआ होगा? 1 time, 2 times, 3 times,
5, 4.
Okay, because now 4 times. इसमें हुआ होगा, insertion would have been at least 1, 2, 3, 4, 5, 6, 7, 8 times minimum. Deletion 1, 2, 3, 4. That's all. Therefore, if you understand this, if I make anything like this, if I am going to write like this, any value of over here, if I write say F, and if I write over here R, it's normal Q, it's normal Q. Now if I am going to write over here, if I am going, this is perfectly valid. If I write like this, हम सबसे पूछे कि बताओ एलिमेंट्स कहाँ पे है, कौन सा एलिमेंट्स फुल है या कहाँ पे जगह खाली है, या हाउ मेनी स्पेसेस आर हैविंग एलिमेंट्स.
4 are having, 1 is empty.
दैट मींस मस्ट यहाँ पे होगा पक्का, यहाँ पे भी होगा श्योर, यहाँ पे भी होगा श्योर, यहाँ पे भी होगा श्योर. तो इसके मतलब 1 is blank because if F has come here, it must have deleted this one. If R is at this place, it must have inserted this one. That means कितने एलिमेंट, नंबर ऑफ एलिमेंट्स कितने होंगे इसमें? नंबर ऑफ एलिमेंट्स will be always equal to 4. अगर ये स्टेटस दिया हुआ है, F is at, now if I ask you, if F is equal to 4 and R is equal to T, how many elements are there? ये क्वेश्चन है ना, 1, 2, 3, 4, 5. ये क्वेश्चन है. इफ 4 पे है और R2 पे है, कितने एलिमेंट्स होंगे? It should have 4 elements.
So, but we should be knowing the length of the queue, because of the queue, the length of the queue can be 10.
See, that has to be given. The max size has to be given. You cannot do it. Therefore, in this question, the max will also be defined. Otherwise, you cannot see. Because अगर ये बड़ा होगा, अगर ये ऐसे होगा, तो obviously ये सब सारा full होगा, है ना? That's okay. You have to give it. Okay, just revise this. In the next class, I will tell you. I will give you some questions, and you try to do it just to test your skills. And plus, I will give you 5-6 questions which from the previous GATE exams which just come. Therefore, all the questions which are there asked in the GATE, I will be covering all those, just to make you prepare better, so that you will be able to have a good grasp for this subject.